Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed, and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. The cantilever beam carries a couple formed by two forces, each of magnitude P 20 kilonewtons. Determine the force R that must be applied as shown to prevent displacement of point A or zero displacement at A. So here's the given figure. Remember, these two couples have magnitude 20 kilonewtons. These forces in the couple have magnitude of 20 kilonewtons each. So let's section it here. Call that x. So EI y double prime equals Rx plus 20 times quantity x minus 7 minus 20 times quantity x minus 6. This one. So EI y prime equals R over 2x squared plus 10 x minus 7 squared minus 10 x minus 6 squared plus c sub 1. By the way, there are c sub 1 and c sub 2 at this end supposedly. But the analysis later would be to set C sub 2 over EI 0 because C sub 2 represents the C sub 2 over EI represents the displacement at A, and since that's the condition that displacement at A is 0, so C sub 2 must be set 0 later. So EIY equals R over 6 x cubed plus 10 thirds x minus 7 cubed minus 10 thirds x minus 6 cubed plus C sub 1 x plus C sub 2. So when x is 12, both y prime and y is 0 at B. So let's begin with y prime first so that we can solve C sub 1 in terms of r and the constants. So 0 equals r over 2 12 squared plus 10 5 squared minus 10 6 squared plus C sub 1. So C sub 1 is 10 times 6 squared minus 10 times 5 squared, then minus 12 squared over 2 of r. So C sub 1 therefore is 110 minus 72 of r. Then here, x is 12, y is 0. So 0 equals r over 6 12 cubed plus 10 thirds 5 cubed minus 10 thirds 6 cubed plus quantity 110 minus 72r times 12 plus C sub 2. So solving for C sub 2, we begin by computing the constants. Let's make this positive. 10 thirds 6 cubed minus 10 thirds 5 cubed, then minus 110 times 12. That's for the constant. Then for terms in terms of r, we have positive 72r times 12 minus 12 cubed over 6. So C sub 2 is negative 3050 over 3 plus 576 of r. Then we should substitute it here. X is 0, so this is 0. This is negative, so ignored. Then C sub 1 times 0 will be 0 also. So what remains is C sub 2. And since we set this to 0 because it is mentioned that we have to prevent, the condition is there's no displacement at A. So that means 0 equals C sub 2. So 0 equals negative 3050 over 3 plus 576r. So from there, we can solve for r. R is equal to 1.765 kilonewtons.